Alright, morning everyone. Let's get started. Okay, so I haven't graded the first test yet, so hopefully you will receive it next week, by Monday. Melissa, have you taken the test? You didn't check the email.
No.
I sent the test to the math center as you requested.
Mm-hmm.
You didn't check.
No.
Oh.
I'm sorry, I was doing
Okay.
stuff for my
Alright.
grandfather.
Okay, so yeah, so you should be receiving the result of the first test by next week, okay? But however, I have graded the assignment number 2 already, and my congratulations to Michael and Samuel. They did the best this time. Okay, so I'm going to return this. Dominic, here. Rachel must be yours because there's no name.
Oh my goodness, I'm so sorry. Sorry.
Jacob? Jeffrey, send up here. Brian, over here. Are you Jeffrey? Should work. Mary Range, not here. Nick, not here. Ian Larson, here. Tyler, Rockford. Preston Hitchcock. So I have to say that again, those who got a pretty lower than 5, please reconsider your plan. Okay, your little behavior. I really want you to go to my center or get together in a group, for example. You just meet Laurie and study with him, or Sama study with her. Okay, I want you guys to get together and help each other and learn from each other. First of all, you learn from me. Then you learn from each other. Okay. So this is the second assignment already. For the third assignment, it's just about graphing. And when you graph, you have to show me the transformation. It means that for each transformation, you have to graph a curve. Okay. Then the transformation curve, you can use the dot line, the dash line, to graph, and the main one will be the solid line, for example, for solid curve. Okay. You can write down the transformation. For example, you say it move up 3 units, left 3 units, something like that, or going down how many units, or reflection over the x-axis, something like that. Try to show me that also, if you can. Otherwise, you don't have to, but you make sure that your graph must be correct. Okay. So on the test that I give you one graph, right? And it looked like that not a lot of students show me the transformation. So you just put into the calculator, and whatever you have on the calculator, you grab it. This doesn't work like that, because this does not show me that you really understand the transformation. And the concept of transformation you already learned in college algebra. Okay? So it's only several of you really grab the transformation. Okay? Alright, any other question? I mean, because this is the second assignment already, and we have about three more weeks until we have the next test. So please, we still have time, okay? We still have time. So reconsider your plan, your learning strategy, your learning method. Get to the math center, okay? And sometime if they couldn't figure it out, just let me know. I can give you a hint. But again, you must get together. Okay? Those who missed the test, well, I don't know if how I'm gonna help you. Just show me how well you will be on the second test and the third test. Then we go from there. Okay. Yes, but you have to do homework and everything else also. Everything okay with homework? Okay, homework is not allowed, right? So in the next few chapter again, we have around really like 8 questions, 10 questions, so that you have more time to focus on the assignment. Alright? Good? Alright, let's continue with our trigonometry function. So last time we talked about 2 functions, the sine function and the cosine function. We investigate the domain and range. We also investigate the property of the function. We know the sine function is even function because the sine of negative x equal to negative sine of x, and cosine function is the odd function. Okay. So today we learn another 4-order function. Hopefully we have enough time to go through all 4 functions. So the first function I want to talk about today. Tuning. Thank you. Okay. Is the cosecant function. Okay. And we know the cosecant function is the reciprocal of what?
Sine.
Of sine. Okay. This is the reciprocal of sine. And because it's the reciprocal of sine, so it looks like that it's likely that the cosecant function that its graph will be based on the sine function graph. Okay? So in order to graph the cosecant, you have to graph the sine first, and from the sine function, we can pick a point, and we connect all the points together to get the cosecant function. But we want to see like if the domain and range will be the same or not, or will be different. How about the period? Probably the same also, right? Okay? So this is the cosecant function, and this is the parents. Okay. When I say the parent, well, it means that the A value, the modular, it could be 1, okay, and B is also 1, okay, and C in this case is 0. So the general form will be similar to what we learned last time. It would be like A cosecant of B of x plus C plus K. So this is the general form. Okay, this is the general form. Okay, again, what A is the amplitude. Okay, if A is amplitude, this is amplitude. And it's always positive. Okay. So if A is turned out to be negative, we know that it's reflected about the x-axis. Okay? And if it's other than that, it's always positive. And if it's greater than 1, so this is stiffer compared to the parents. We're going to talk about the parents of the cosecant soon. Okay. And if it's less than 1, I think the other way around. Let me check one more time. So yes, this is no, that's good. So this is less than. And we can find the phase shift using by setting up bx plus c equal to 0 also. So if we set bx plus c equal to 0, and we know that, so we can have x equal to negative c over b. And it represents the phase shift. It means that how much unit you move to the left, how much unit you move to the right. If negative c over b is greater than 0, okay, we know that it's moving to the right. Okay, if negative c over b greater than 0, we know that it's moving to the right. Okay, it's moving to the right. Same as last time. And if negative c over b is less than 0, and we know this is moving left. And the k value is also to represent the vertical transformation. If it turns out to be positive, we know that it's moving up, k unit. If it's negative, it moves down by k unit. Okay. So now I'm going to replace a with 1. Okay. If a equal 1 equal b, and c and k equal 0, then we have the parents function, right? Then we have f of x equal to cosecant of x, and this is turned out to be 1 over sine of x. Now let's investigate the domain of 1 over sine of x. And we want to see if it is the same as sine of x or not. Okay? And we also want to investigate the period also. Okay? So you see the f of x equal to 1 over sine of x. This function is in fractional form. And if it is in fractional form, you already learned in college algebra. You learn one of the basic function we call the rational function. One of the 6 basic functions in college algebra. It's rational function, and because it's rational function, or I can say it's in fractional form, the denominator in this case will be sine of x. Okay, it cannot be 0. Because you cannot divide by 0, right? You cannot divide by 0. Because if it is 0, if sine of x equal to 0, the function is not defined. Because if sine of x equal to 0, we have 1 over 0, it doesn't work. We know that. Some student, I don't know why they put 1 over 0 turned out to be 0. So that is very terrible mistake, okay? Okay. So at what value make the function undefined? That's the question we want to ask us. Okay? Because we know that sine of x cannot be 0. Okay? We know that sine of x cannot be 0. This is cannot be 0. We want to find the value of x. such that the function over here, the whole function over here, defined. And we know that there's some value of x such that the sine of x turn out to be 0. Okay? So, if we can find the value of x such that the function undefined, then the rest of them will be defined. You know, I don't know if you guys remember how to find the domain of the function when you learn college algebra. You know, something you solve, you set the denominator equal to 0, right? I know some instructors show you that, right? Then you write your domain in interval notation form. So this is the same thing like that, okay? You set the denominator, well, actually, I never say set the denominator equal to 0, that is like most of the instructors say. I always say set the denominator not equal to 0. Because we cannot set it equal to 0. If it equal to 0, then it's not defined. Okay? So in order to find all the value that make the function defined, remember, find all the value that make the function defined, we find the value that make the function undefined, then the rest of them will be defined. Okay? And we know that there's some value here. There's some value when you plug into the x here, when you replace x with something and you take sine, it makes the function undefined. Okay. Now, anyone can tell me what will be the value of x, what will be the angle, so that when you take the sine of that angle, it turns out to be 0. I want you to consider this unit circle. I know this is sine. This is 1, 0, negative 1. What will be the angle so that when you take the sine of that angle, it turns out to be 0? Yes?
0.
0. One of them is 0. Yes. One of them is 0. Anything else? Yes. Yes.
360.
What's that?
360.
360, so it means 2 pi. Very good, 2 pi. Okay. Anything else?
Just pi.
Pi work, yeah, because pi over here turned out to be 0 also. Any other than that? Pi over 2, well, if it's pi over 2, it turned out to be 1. Yeah, because pi over 2 90 degrees, right? It's 1. It's pi, then it's turned out to be 0. Because you just imagine the angle, initial side and the terminal side. You see that? If it's pi over 2 like that, then it will be 1. But if it's pi, it's 0. If it's pi, 0. If it's 2 pi, to go backward like that, it's 0. Okay, 0. Okay. Any other than this value? Or maybe that's it. Only 3 of them? Yes.
So could we use like 3 pi also?
3 pi? Well, yes. Because just imagine 3 pi. So do this is 1 pi, right? 2 pi. 3 pi go back to this position. So 3 pi work. 3 pi work. And maybe 4 pi also.
And 5 and 6.
And 5 and 6. So if I say, if I call k represent from 1, okay, from 1 to n, I can write a general solution for that, right? Or I can go backward. How about negative pi? It still turns out to be 0. Or negative 2 pi. So I can write sine of x different from 0 if x, okay, is different from k pi. With k is 0, plus minus 1, plus minus 2, and comma, and so on. Okay. So what does it mean by this? It means that if x equal to k pi, the function is not defined. That's why x must be different from k pi. This is for the domain. Okay, x must be different from k pi, because if x equal to k pi, sine of x turn out to be 0, and sine of x turn out to be 0, you're not allowed to have 0 in the denominator. Okay, but we want to write, let me see, can we write interval notation? It would be very hard to write interval notation, actually. Yes, it would be very hard. So this should be the domain. So you're gonna write like this, okay? You're gonna write like that. You don't have to write interval notation for this case. Well, it will be a bunch of them. Because it's different from k pi, so it could be different from 2 pi, 3 pi, negative 2 pi. So that would be a lot. That would be a lot. Yeah, you have to do union a lot, many times. Yes.
Would interval notation always be in radians?
Oh, you mean in radian unit like that?
Yeah.
Yes. I think you can use K180. That's fine, but not a lot of people use that way, including the textbook. All right. So the domain will be everything. The domain will be everything on the number line except for k pi value. All right, everybody clear on this? Okay, except for k pi value. Okay, so that will be the domain of the cosecant of x. So it's different from the domain of the sine, right? Because the domain of sine is what? Everybody remember what is the domain of sine function?
All real numbers.
All real number.
Plus minus 1 to 1.
Oh, that is just for the unit circle.
Oh yeah.
Because for the sine, we have to draw, you can draw it. So it will be all real number. Negative infinity to positive infinity. Okay? Alright, how about a period? If this is the period, it will be the same or not? Because the cosecant is based on the sine function. And what is the period of the sine function? 2 pi. So the period of the cosecant also 2 pi. So in order to find the period of the general form, I'm sorry I forgot to mention that, the period will be the same, will be 2 pi over b. How about the range? The range will be a little bit different. What is the range of sine? Anyone know the range of sine? The sine function? 0 to 1. 0 to 1. Well, just that is just the top part.
Minus 1.
Negative 1 to 1. Yeah, you just talk about the top. Okay. So the range of the sine function is between negative 1 and 1, because you remember sine function that look like this, right? And over here it's 1 here, and over here negative 1. So it's between negative 1 and 1. That's just for the sine function. How about the cosecant function? It's a little bit different. Okay. For the range of cosecant function, it will be from negative infinity to negative 1, union with 1 positive infinity. And I will explain why we have that. The reason we have it because it's based on the sine also. Yeah, when you set up the sine, the table value, and when you graph it, the range is just like that. So I want right now just go ahead and take it for granted. The range like that, the domain will be like this. Now I want you to consider one of the examples. I want to graph. Let's see. F of x equal to 2 cosecant pi over 2x minus pi. Okay, so how are we going to graph this? Of course, because this is look like it's in general form because the amplitude is 2. Okay. The b is not 1 anymore, the b is pi over 2. And the c is negative pi, so what we have to do, we have to graph the sine of that. Okay, so I'm going to just change it to the sine. Oops. 2x minus pi. I'm going to grab the sine of that on using the basic function of sine function, and we grab it on the period. Okay, after we calculate the period using the b value right there. So first of all, go ahead and calculate the period. Period, I'm going to use this formula right here. 2 pi over b, and it will be 2 pi over 2. Okay. And after we calculate the period, we also have to calculate the horizontal transformation. And we want to know if how much unit go to the left, how much unit go to the right. So this is turned out to be what? 4, right? So the period will be 4. Okay. It will be 4. And now let's calculate the phase shift. The phase shift we call this horizontal transformation. In order to be good at trigonometry, you guys have to do a lot of practice. I have to say a lot. In order to master trigonometry, you have to do like 1,000. Of course, right now you cannot master. UK is good enough. You just need to get an A. And really understand the material. But in order to do like anyone can give you the problem, and you can do that. You have to do 1,000 problems, more than that. Okay, so phase shift, we're going to set bx plus c equals 0. So whatever inside the parentheses will be bx plus c. So we're going to have pi over 2x minus pi equals 0. So we have here which will be what? Pi over 2x equal pi, right? X will be what? 2. So if x equals 2 and 2 is positive, so it moves left or right?
Right.
Right. Right. Let's move right. Right shift. Okay. Alright, so that's the phase shift. That's the period. The amplitude is 2 already, the amplitude. Amplitude doesn't matter. We just mark anywhere on the vertical, on the y-axis, and then put 2. Okay. So that's good enough. All right. So let's graph. Okay. All right. We don't have vertical transformation because the k value here is 0, so we don't have it. So this is again, we're going to mark the period. The period will be 4. Just kind of like this, okay? We want it like this. I want an interval for that period is 4 like that. Sometimes you have to scale it because sometimes you need to know like you have enough space or not. Sometimes you want a period smaller than this. And just set 4 over here. Sometimes you can put 4 over here. It doesn't matter. Okay, as long as you have enough space, then you can mark everywhere you want. Okay. So that's 4, and the amplitude is 2, so maybe something like that. Okay. So just have 2 is half of 4. So actually, you can put 2 down here, that's fine to me. Okay. And you see the cosecant is based on the sine function, so I'm going to grab the sine function with amplitude 2, period 4, no transformation yet, okay? So I'm going to just go ahead and draw the sine function first. And the sine function, everybody already know that's going to look like this one, right? That's what I want you to memorize. It's very important, okay? They look like that one, so half of this will be 2, okay? Over here will be negative 2. Okay, so we're going to have a curve that looks like this. So I'm going to use the dashed line because it's not the main one. Something like that. I know. So this function is f of x equal to 2 sine pi over 2x. Because the period is 4, so we have to derive pi over 2. Okay. So we haven't done any transformation. Yeah? I didn't write transformation here. It means we have not shifted to the right or left yet. Okay. Now I'm going to shift. Okay? I'm going to shift. And I want 2 units to the right. So I shift the whole thing, move to the right. Alright, I move to the right 2 units. Okay? So let's see how I'm going to move it. So this one becomes this one becomes that, and 4 becomes 6. Okay, 4 becomes 6. So it becomes like this, right? Alright. Here you go. I already shifted 2 units to the right. Okay, everybody clear? Just shifted 2 units to the right. So the function I have right now will be f of x equal to 2 sine pi over 2x minus pi. Alright. Now, you know that the domain here will be everything else except for k pi. And again, let's go back to the rational function you were learning in college algebra. The value that makes the function undefined will be where the vertical asymptote goes through. I don't know if you guys remember that. For example, back in the day we learned the function rational by function is 1 over x. And we know that at x equal to 0, it's undefined. And if it's undefined, we had a vertical asymptote. You know? F of x equal 1 over x. Undefined at x equal to 0. That's why the vertical asymptote like this. Vertical asymptote like this. So at the value that make the function undefined, we have vertical asymptote. So the function is undefined at where? Oh, we need to find that. Okay, so over here will be all the value of x some way somehow, such that the bottom cannot be 0. Okay. Because you have not learned how to solve this function. Because this one is easy, right? This one is easy. You can get by using the unit circle. Okay. So all the value will be k pi. But this one will be hard. And because this one will be hard, I'm going to use the original one, okay, which is this one, sine of pi over 2x, okay. So the vertical asymptote will be what value such that 1 over sine over pi over 2x turn out to be 0, and it's always over here, okay? It's always over here. Right here, and right here. And now when we shift 2 units to the right, the vertical asymptote is following that. So the vertical asymptote right now is here. There you go. So how many vertical asymptotes? Because we have a bunch of values that make the function undefined. We have infinite many vertical asymptotes. Okay, so we have 1, 2, 3, and a lot more. And on the left side, we have a bunch more. Okay, so we have infinite many value or many vertical asymptotes. That's where the function undefined. It means that the function of cosecant cannot cut the vertical asymptote. All right. So right now I already graphed 2 sine pi over 2x, okay? Right. Now we already shifted pi, 2 units to the right, okay? But that's just a sine function. It's not cosecant yet. So in order to get the cosecant, okay? In order to get the cosecant, and the cosecant is the reciprocal of the sine, okay? So from here, you're going to make a curve because of the reciprocal. So from the top point right here and the lowest point here, you're going to make a curve that looks like this. And it never cut the vertical asymptote. So you have another one. Look like this. Okay. So right now I have the graph of the cosecant on one period. This, there you go. You don't have to erase that. Right? So the red curve will be our answer. Okay? It's just for one period. And if they want you to do more than one period, of course, you will have a bunch of them. So you're going to have over here, you have something over here, okay. And of course you can have something over here also. Alright?
And when you say it's for one period, meaning?
For one period it means that,
how do we know it's for one period?
for period is from 0 to 4. Because the period is just 4. The period is 4.
Oh, okay.
So after we shifted, it become 2 to 6. Because I shifted 2 units to the right. From 0 to 4, I shift 2 to the right 2 units, it becomes 4 to 6. Okay? It becomes 2 to 6. I'm sorry. Because I shift from 0 to 2, 2 to 4, and 4 to 6. Okay? So that is one period. So the one period does not have this. Okay? Only this and that. Okay? But it depends on, for example, depends on the question. For example, the question over here, I want you to graph between 10, negative 10 and 10, for example. Then you have a lot more until you get 10. Okay? And you have a lot more over here also. Okay? Any other question? And the reason I can get the curve over here is, again, you can use the table value, but I don't want to go through the table value. As long as you know the sine function, you can make a curve like this. Okay, you don't have to go to the table value. You can go to the table value also, but you look at that. You have to plug over here. It's very complicated. So I don't want you to do that. Okay, just make a small curve write that and make sure that it never cut the vertical asymptote. Okay? Any question? Yes?
It seems like the y value where it starts to be 4, because cosecant at pi over 6 is 2 without the amplitude. Does that make sense?
No.
No?
We still, you mean that it start over here at 4 instead of 2?
Yeah.
No, we don't shift it.
Uh-oh.
We don't shift it. So it's still at 2 right there. It's still at 2. Because the original one, this one, we start at -1, but over here the amplitude is 2. So we start at 2. I don't think we start at, no, it's no 4 over here. You mean because when you plug the value over here?
I'm just talking about when it's pi over 6, that's equal to 2. Cosecant of pi over 6 is equal to 2.
Pi over 6 is not equal to 2.
Oh.
It's 30 degrees and it's.
Pi over 6 is 30 degrees. Oh yeah, 30 degrees, yeah. So
what does
yeah.
that make that?
No, it's not going to work like that. So whatever the amplitude here, we always start with that. Unless they want you to add the vertical asymptote at a certain unit over here, then you move up. For example, over here, if I add 2, then I move this up 2 units, so it becomes 4 over here. It becomes 4 like that. But other than that, you don't have to. No. Whatever you start with the amplitude, that's what it is. Okay? Because
Thank you.
you mean that when x equal to pi over what did you just say? Pi over
Pi over
6.
6, yeah.
Pi over 6. Pi over 2.
Well, when
It's not gonna work
when
like
cosecant is pi over 6, not x in that case.
Okay, I mean you can put pi over 6 here, right? X equal to pi over 6. Now, it's not going to pi over 6 right now, because over here the value is in radians, so pi over 6, yeah, you can change it like that, yeah. So pi over 6 will be what? Pi times pi square.
I'm just talking about the whole parentheses equal to pi over 6, not x.
Oh no, it doesn't work like that. It doesn't work like that. You cannot replace the whole parenthesis. Because if the whole parenthesis, pi over 2, x minus pi equal to pi over 6, then the x will be different now. The x will be somewhere, it's not at over here anymore. It's not at 3 anymore. Because you want it at 3 so that you get 4. So, what is the value over here? Pi over 2, x equal pi over 6 plus pi, right? It will be what? Pi over 2, x will be 7 pi over 6. And you have what? It will be 7 pi over 3. It's not here. So it don't start over here anymore. It's starting somewhere 7 pi over 3. 7 pi over 3, you plug into the calculator. It will be what? 7 times 3.14 divided by 3. It's not at 3. So it must be somewhere else. But it's not here. But you want over here because this is the bottom, the lowest point of the cosecant. Okay. All right. Any other question? Okay. So right now, when you grab the cosecant, you look at the amplitude. Okay. If the amplitude here is 2, you just mark 2. Okay. If it is like 4, you mark 4. And if it move up 2 units, you just move the whole thing up 2 units. Okay? That's simple, like that. Alright, so that is for the graph. Any other question before we jump to another function? Okay. So that is the graph for the cosecant function. The second function I want to talk about today is the secant function. Okay, and the general form of secant function will be the same as cosecant. So we have f(x) equal to a secant of bx plus c plus k. And the cosecant function is based on cosine. So the period again will be, in this case, will be 2 pi over b. Phase shift will be the same. So I don't want to write it, so it's the same as the other one. Okay. The amplitude also the same. Okay. Now I'm going to replace again. Now I'm going to replace A with 1, B 1. So if A and B equal 1, and C and K equal to 0, my function become f of x equal to secant of x only. Becomes secant of x only, and secant of x equal to 1 over cosine. We want to see that, we want to investigate if the domain of the secant is the same as the domain of the cosine or not, or the range will be the same or not. Okay? And you see that 1 over cosine is in fractional form. And if it is in fractional form, we're not allowed to have 0 in the denominator. It means the cosine, okay, so it means cosine. The cosine of x must be different from 0. Cosine of x must be different from 0. Because if the cosine of x is equal to 0, we're not allowed the function undefined. Okay? Because if 1 divided by 0, undefined. So cosine of x must be different from 0, and we need to find all the value of x. Okay. The value of x, so that cosine of x equals 0, or the value of x so that the function undefined. Now, again, now we're going to look the unit circle. This is cosine. This is 1, 0, negative 1. What will be the angle so that the cosine of x turns out to be 0? Yes? Pi over 2. Wonderful. Pi over 2. Any other angle? Yes.
3 pi over 2.
3 pi over 2. Very good. 5 pi over 2. 5 pi over 2. Everybody agree with that? Yeah, 5 pi over 2.
7 pi over 2.
And so on, right? So we have odd number of pi over 2. So in general, I can write it as x different from k pi over 2. This will be different from pi over 2, 3 pi over 2, k pi over 2. Or sometimes you can write it as x different from pi over 2 plus k pi. It's the same thing. With k equal to 0 plus minus 1 plus minus 2, because you can go clockwise also. Clockwise. Okay, so that would be the domain. So we have the vertical asymptote right here. The same as that one. Because when x is different from k pi, we have vertical asymptote at 2 pi, 3 pi, 4 pi. Okay? So right now, we have a vertical asymptote at pi over 2, 3 pi over 2, and so on. How about the domain? Oh, that's the window domain. How about the range? The range will be the same as the cosecant. So the range will be from negative infinity to a -1. Okay. Union with 1 infinity. Okay. So if I graph the cosecant, the basic cosecant, the parents. Okay. Let me grab the parents. Okay. I'm going to grab this one, okay? Secant of x. It will be like that. Right now I know that the period, again, the period is to be 2 pi over here, sorry, because b equal 1. So the period will be 2 pi. Okay. Because it's based on the secant, so based on the cosine, and then the period of cosine 2 pi. So the period of cosecant is secant, it would also 2 pi. So I know that will be right here. You can mark whatever you want, depending on how much space you have. The amplitude right now we have for the secant will be 1. So remember the graph of the cosine, guys? What is graph? What it look like? We start with our origin, or we start with at 1? How about that? At 1. So it's different from the sine. Okay, the sine will start with the origin. So we start at 1 right here. So it's -1. So we go like this. There you go. So that is the graph of the cosine. But in order to get the cosecant, we make it reciprocal, and we know that the vertical asymptote is where the function undefined. So the vertical asymptote is f pi over 2, 3 pi over 2. Okay, because I'm graphing only one period. Okay, so we have only two vertical asymptotes. Okay, we have only 2 vertical asymptotes in one period. Of course, it depends on how many periods I wanted to do. Then you have more vertical asymptote. Then the cosecant, the secant, I'm sorry, the secant will be like that. There we go. And here we go. Okay. Remember, this is a vertical asymptote, okay? So when you graph, don't ever cross. My secant graph never crossed the vertical asymptote. If it crosses, it will be wrong. Okay? So don't cross it. Vertical asymptote, we get close to the asymptote, but we never cross the asymptote. We never cross the asymptote. Alright? So that's the graph for the secant. Okay, that's the graph for the secant. I think I should graph the cosecant over there too. I mean, for the basic one. Let me graph the basic one for the secant over there. I'm sorry, guys. Let's go back to this a little bit. So let's just help you understand better. So I'm going to graph the secant also. Cosecant, sorry. So the cosecant based on the sine, so I'm going to graph the sine first. So I know the sine, the period is 2 pi. And for the sine, we start at 0. This is 1, negative 1. Yeah, right? Okay. And we know that the amplitude will be, the vertical asymptote will be at k pi. So it will be at pi and 2 pi. So we will have vertical asymptote right here. Okay. And we're going to have the cosecant that look like. Hey. So you always start with the basic, with the parents function. Okay? Well, you always start with the parents function. then you apply transformation. How many units you go up, how many units you go down, correspondingly to the new period. Because if I give you something like that, right, the period is not 2 pi anymore. The period will be 2 pi over b. Okay, it's not 2 pi. If it's the basic one, so for this is the graph of the cosecant. This is the graph of cosecant. The period is still 2 pi. The graph of the secant, only the period is still 2 pi. But if I give you something like this, the period will be different right now. All right? Okay? Any other question? You have to do a lot of practice to really understand, well, to master this. Okay? Do a lot of graphing. Okay? Any concern? Larry, any concern? Good? All right. Okay. Any other concern? Rachel? Good? Good. All right. So that's just the graph for secant and cosecant. Let me do another example when we're dealing with secant using transformation. How about doing this? Okay, let's see. How about I want to graph. Oh my God. So let's do over here. Alright, so the example for the secant, I want to graph f of x equal to secant pi x, okay, plus pi over 2. Alright, again, first step, because right now the period is not 2 pi anymore. Okay, so this is in general form right now. So the period will be 2 pi over b. It means the period will be 2. Oh. So a little bit different. Last time we had period 4. Okay, so right now the period will be 2 pi over b. Your b is here. And we want to know like how much is go to the right, how much is go to the left. So we calculate the phase shift. We what? Pi x plus pi over 2 equals 0. Then x equal what? X equal what? X equal. What do you think?
-1/2.
Negative half. Negative half. Now you move left or right? Tell me.
Left.
Left because it's negative. How many units you move left?
Half.
Half unit. Half unit. Okay. Relatively to the period, because the period is 2, so half will be half of 2 is 1, and another half will be a half. Okay. So I got a pair of phase shift already. The amplitude is 1, so it doesn't matter. You know, actually the amplitude is not gonna give you a big concern when you graph the trigonometry function. Okay. All right. Let's see. I'm gonna erase over here. Okay. Okay, let's start with the parents function. Alright, and for this one I want to graph between -1 and 1 only. Okay, so I don't want to graph between -1 and 1 only. I don't want you to graph the whole on the whole number line. So the period is 2. I can mark anywhere. This is 2. Okay. So half of 2 will be 1. I know the amplitude will be 1. So 1 something over here. No vertical asymptote. It means that we don't have to worry about it moving up or down. So it looks like we have enough space for that. Got a k value equals 0. So secant is 1 over cosine. So let's start with the cosine function first. Always start with the basic one. Okay, cosine function that look like this. Okay. I know that a cosine function, the vertical asymptote is at half, you know. So this period over here, so a period is 2 pi over here, so the vertical asymptote at 3 pi over 2, so the vertical asymptote over here will be 3. Okay. And anywhere else at 1. Oh, at 1/2. There you go, that's the vertical asymptote. Okay. Now we're going to shift half unit to the left. So I'm going to shift the dash curve, okay, the dot curve, half unit to the left. Alright, so I move the whole thing here to the left. So this is negative half right here, right? So I move the whole thing to the left. So it'll become like that. This will become like this, and like that, like this, and like that. So you see that the vertical asymptote is not at this line anymore. It's somewhere else. Okay, so the vertical asymptote will be here. Because when you move the graph, you have to move the vertical asymptote along. Okay, you have to move everything. So the vertical asymptote here will be right on the y-axis. Okay. And now we want it between what? We want it between -1 and 1 only. Between -1 and 1 only. So we want it just between here. -1. Oh, I think I messed up with the 1, right?
That should be -1.
That's it. We want it right here. So I want it right here. This is -1 right here. Because this is -1/2. I want it between -1 and 1 only. So I want it between right here and right here. This is 1 right here. Okay? I want it between right here and right here only. So I have to draw another curve down here. There you go. And we want to delete this curve because we want it between -1 and 1 only. Can you guys see that? Okay, there's kind of a lot of curve right over here. But I mean, we have to do transformation because this helps you understand it. So right now I have it between -1 and 1 only. Okay. Again. Okay, my curve right now. My cosecant curve right now will be based on the red curve of my secant. So it will be what? It will be something like this. Now this is another vertical asymptote. Okay. So my secant will be this. Right, and between -1 and 1. Can you guys see that? Usually, I mean, when you graph all the same coordinate system, there's a lot of graphs overlapping each other, but you have to use different color to tell difference. Okay. Any concern here? Okay. So I move. First of all, I grab the basic. Okay. I draw the vertical asymptote. Okay. Then I grab the transformation. You always do that. Grab the basic, the parent function. Grab the vertical asymptote. Then grab the transformation. Okay. Then from the transformation, we can get the secant and cosecant by just make it reciprocal. Make it reciprocal. Any question? Good. guys have to practice a lot. And again, you have to memorize the basic. If you don't memorize the basic how it look like, then you cannot graph this. I mean, you can use the calculator, but you have to be careful because the calculator sometimes it's on the x-axis. The calculator is 2, 3, 1, 2, 3, 4, 5. It's a whole number. It's just a positive value. Over here, negative value. Here is a whole number. But if it's like pi or 3 pi or 4 pi, I don't think they're going to show 3 pi and 4 pi and 2 pi on the x-axis for you. So the calculator is good for you to check the graph, but it's not really perfect. Yes.
In homework, they often mention even and odd, so this actually reflects that, right?
No, this one you don't have to worry. An even and odd in this case. Let me see. No, this is not a reflection. This is still a part of that. Okay, it's still a part of that. Unless I want to put a negative here, then you're gonna flip it over. But it's still a part of it. But the original, when you're talking about the original, you're talking about this one, right? Because a sine is what? For example, over here, sine is even or odd?
Odd.
Odd. If sine is odd, sine of negative x equals negative sine of x, right? Okay? So cosine will be odd too. Okay? Cosecant of negative of x is 1 over sine of negative of x. And sine of negative of x is, because sine of negative sine is an odd function. I already mentioned that in the previous lecture. They give you 1 over negative sine of x. And you see that it's the same. Yeah, so we give you cosecant of negative x equal to negative cosecant of x. So yes, cosecant of x is odd also. You can check that. Okay? And same thing for secant. Secant will be yes. This is even, not odd. Sine of negative x equals to sine of negative x equals negative sine of x. It's even or odd. Let me check.
Odd. Sine is odd.
Let me
Cosine
check.
is even.
Yeah.
I remember from homework.
Yeah. I'm sorry. Yes, it is odd. Yeah. Okay. And cosine will be even. Okay. Because cosine. Let me check cosine. So cosine over here, right? So cosine. Cosine. We know cosine of negative x equals cosine of x. Okay, and secant of negative x will be 1 over cosine of negative x. Okay, so that's why I give you cosecant is 1 over cosine of negative x, because cosine is an even function, right? Okay, so give you cosine of x only, and that's why it turned out to be odd over here too. Okay. So you have to memorize a lot of property, guys. You have to memorize a lot of property. You have to memorize the basic function, the graph. Okay. For even an odd property, you don't have to use that much. You just use it when you evaluate a function. But when you evaluate a function, I already show you how to use the reference angle, the quadrant. So you don't have to consider that. But it's good. It's good if you know the sine of x, sine of negative x equal to negative sine of x. It's faster. Okay, instead of you check the quadrant and you know, okay, this quadrant sine positive, negative. Okay. If you guys watch the solution of the first assignment, you got to watch the video. I mentioned in the video also. Okay, so I just use the quadrant instead of I don't want to mention even and odd over here. It's more confusing to you. Okay. Any other question? So everybody okay with secant and cosecant? Okay. Now let's do another function. We have another function to talk about. Okay. Right now we learn a sine, cosine. Okay. Cosecant, secant. There's another function. You guys want to know what it is? Tangent. Good. Let's talk about tangent. Tangent function. talk about the general form of tangent function, and we want to see is investigate if it is the domain, it will be the same or it will be different. Okay, so the A tangent B x plus c plus k. Actually, k is not a big problem in this case because actually when you shift it up or down, it's not much changing. Okay, but I just included that. It just changed a little bit in terms of the graph. Okay. All right, now the period. Okay, so the period, instead of 2 pi, the period of the tangent will be pi only. So the period over here will be pi over b only. So instead of 2 pi over b. Okay. So the phase shift will be the same, amplitude will be the same, so I don't want to include that. So everything will be the same. The k value, you know, that is moving up or down, okay, or negative c will be then moving left or right, okay. All right, now let's put a equal 1 equal b and c equal k equal 0. My tangent function general form become f of x equal to tangent of x. Okay. And if we change tangent of x using the one of the property we already learned, tangent equal to sine over cosine. And now I realize that tangent function is also in fractional form. And every time in the function in fractional form, you have to consider the value that make the function undefined, which is the domain is not from negative infinity to positive infinity anymore. It must be something else. It must be everything except for the value that makes the function undefined, or except for the value when you have the denominator turn out to be 0. Okay? So the domain here will be everything except for cosine equal to 0, or will be cosine, you can say in other words, cosine must be different from 0, because if cosine equal to 0, it's undefined. So the cosine must be different from 0. Okay? If cosine different from 0, okay, now look at the unit circles, cosine. Oops. It's cosine here. So I have 1 here, 0 here, 1 here. So now anyone can tell me what the angle if cosine equal to 0? Pi over 2, again, it's kind of the same as that one, right? So we have pi over 2, we have 3 pi over 2, we have negative pi over 2 if we go clockwise, okay? Or we have negative 3 pi over 2 if we go clockwise, or we have 5 pi over 2, and so on and so on. So I can write the domain in general form will be x will be everything different from pi over 2 plus k pi, with k equal to 0 plus minus 1 plus minus 2, and so on. So that will be the domain. That will be the domain. And you see that because that's the domain over there, we had a vertical asymptote at pi over 2, at 3 pi over 2. So we also have vertical asymptote. The same thing as we have asymptote for the secant. And yes, for the secant, yes. And the cosecant also. Okay. All right. So let's see how we can graph the tangent. Let's see how we graph the tangent. And the tangent will be also odd function, because tangent equal to tangent of x. I can check it even and odd really quick. Tangent of negative x equal to sine of negative x over cosine of negative x. And we just know, Vijana just mentioned that sine of x is even is an odd function. Okay, it's an odd function. So sine of x equal negative sine of x, and cosine is even function. Okay, so cosine of x equal to cosine. Cosine of negative x equal to cosine of x. So you see the tangent of x equal to negative tangent of x here. And if tangent of x, tangent of negative x equal to negative tangent of x, we already learn even an odd concept, f of x, f of negative x is equal to negative of f of x. One of the concepts we learned in college algebra. We know that this is odd function. Okay, so tangent is odd function. Okay. So that's just the way I check. Okay, I check what I use, what are the concepts we learn in college algebra. So tangent is okay, and same thing for cotangent. And we're going to talk about cotangent next also. Okay, so that is the domain. Oh, we don't have enough time, so let's stop over here. So next time I'm going to grab the function of the tangent, then we keep talking about the function of cotangent. Okay, thank you so much. Go ahead, sign.